Welcome to a lesson with Dr. Powell. Let's take a look at how we would find the total force uh, that is exerted by water on a dam. Let's start with an example where we have a triangle. Now, we're going to also use the idea that pressure is equal to the derivative of force with respect to area. At least that's what we're going to define pressure to be. If we know what force is, or we know what force is, we can define pressure to be this. Just kind of a rough idea. And we're also going to think about pressure as being constant at a particular depth. Okay, so we can think about, so pressure will change as the depth changes, which changes as, so we have a natural idea of area changing, maybe area of this as we go along. So maybe here, the area of the right here on the, maybe the water's right at the top of the dam, let's just say for simplicity. So the area up until this point, what's the little change of area is a little piece, even a little rectangle right here, little dA. So, and so a little piece, so in particular, a little piece of force is going to be equal to pressure, which is constant at a particular depth, times dA. So to find the total force, we could create an integral, which would compute. So we could create an integral which would compute this. So we have pressure times the little change of area here. Okay, so pressure also, it can be computed simply as 62.3 pounds per cubic foot, but then times depth. So really that's 60. So we get 62.3 times depth. So let's suppose that depth is x times x. That would be pressure. And the units of this pressure are pounds per square foot, since the feet cancel here. So it's kind of like an area type thing. In fact, very much so. Pounds per area, pounds per square foot. Okay, so that's what pressure is. So what we have is we basically have 62.3x multiplied by the change of A, which can be thought of as a rectangle like this. So a little height of that is dx, and the length of this, well, it depends on the specs of the triangle. Let's suppose that the triangle was, let's suppose that we do 30 and 20. Okay, so that means this height right here would be 30 minus x. And you notice that the base is always 2/3 of the height. So this right here would be, because 20 over 30 is 2/3. So this would be 2/3 of that height. So, right, so we have base times height. So we have base is 2/3 times 30 minus x. But then we multiply by 30 minus x again, since it is the 30 minus x is the height of that triangle. Oh, no, we're not doing that. We're just finding dA. Sorry. Yeah. All right. Getting lost in what I'm doing. All right. So very good. So 2/3 times 30 minus x would be this length. And then we want to take that length and multiply it by dx. Okay. And right, that is dA. And that's exactly what I wanted. And x is going from 0 to 30. And this little computation will allow us to find the total force of dam. Okay, so we can go ahead and proceed. Let's do, okay, so let's take that. So let's say 62.3 multiplied by 2/3. And then we have the integral from 0 to 30. And then we have Just distribute that in. So 30x minus x squared dx. We take an antiderivative of that. So we get 15x squared minus x cubed over 3, going from 0 to 30. 62.3 times 2/3. And we see, right. Well, okay. Let's just think about this for a second. If this was still 30 over 2, maybe that would be easier in the computation. Let me think of that. All right. 30 over 2, because then this looks like you plug in a 30, you end up getting 30 cubed, 1/2, 1/3. So it's like 1/2 minus a third, which is a 6. So it's really a 6 of 30 cubed, which is 27,000, and you're taking a 6 of it. So 27,000, and you're taking a 6 of that, and you're multiplying that by 2/3, and 62.3. And the units for this force should be pounds when we work that out. When we plug in 0, we just get 0. So we're kind of taking that into account here. Plug in 30, get something. Plug in 0, get something. All right. And then we could simplify this a little bit. Yeah, so 1, 3, so you get 9, and 9 and 27, that would be 3. So really, we end up getting what, 3,000. So we should get 62.3 multiplied by 3,000 pounds, which would be so 180. So that's what, 180, and then 6.9. So 186.9. But then you have the 3 zeros, so just erase that. So yeah, I'll put a comma there. 186,900 pounds of pressure is the total pressure exerted on that dam. All right. Thanks for watching.